Okay, so we've done explicit formulas for arithmetic, and now we're going to do it for geometric. Again, so people don't get confused. All the equations that we have done so far are considered to be explicit formulas. Specifically, if it's adding or subtraction, it's arithmetic, and it's geometric, it's multiplication or division. But they're called explicit formulas. That's the generic sort of blanket that they all fall underneath. So we're going to talk about how to do those. So here we go. First thing you do, and hopefully from the last video you noticed that that you need to write all this stuff down because you need it. So here is the formula for geometric sequences. Again, we start off with an a sub n. A sub n is the term you are looking for. So if I'm looking for the fifth term, then I would put a sub 5, because that means I'm looking for the fifth term of the sequence. If I'm looking for the 100th term, I put a sub 100. Then a sub 1, that's the first term, not the initial. Why? Because the initial amounts before you started. And if you have any sequence, say I have a sequence 2, 4, 6, 8, all sequences start with that first term. We don't start with the initial term unless we're looking at tables. On tables, you can have an initial amount. But on a sequence, we always start with the first term unless they label the terms. So, and then instead of a difference, we're talking about a common ratio. And then you notice here it says to the n minus 1. So the difference is because it's exponential, instead of being times, it's to the power of. So this is your formula. Remember, geometric sequences are used to show exponential growth or decay, meaning exponential equations. So let's go ahead and try one. So hopefully you've already written this down. If you haven't, you should do it now. Here is a sequence, right? I want to write the explicit equation. And the reason why I want to write the explicit equation is because instead of having to do this again and again and again, if I write the explicit equation, I can find any term in a sequence. I can find the 10th term, I can find the 1000th term. But to do that, I'm going to need some pieces of information. I'm going to need to know what the first term is. The first term here happens to be a sub 1 equals 1. Really quickly, on a side note, kids do this a lot. That's A1. That's like bingo. You don't put A1, it's subscript. It's A sub 1. So 1 is my initial amount, and then I put parentheses, and then I look to see if I have a rate. Well, I was actually starting to do my formula, but let me stop for a second. Explicit form, I need the first term, and then I need to know what the rate is, if it is a rate. So I look and say, okay, first thing I always try is addition. 1 plus 1 is 2, but 2 plus 1 is 3, so I know it's not addition. And plus, we also know that we're dealing with geometric right now. The other thing I can do is try times 2. Well, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So I think we have a ratio, and that ratio is 2. Now that I have these things, I can write the equation. The explicit equation is this. It's a sub n equals a sub 1 times r to the n minus 1. Okay, so how am I going to write that out? A sub n stays a sub n because I want to be able to find any term in the sequence. A sub 1, well, that's my first term, and that was a 1. R, that was 2, that was my ratio. And then to the n minus 1. So this allows me, if I want to find a 100th term, I would put 100 here and here. If I want to find the 90th term, I put a 90 here and 90 there. But in this case, they're asking to find the 10th term. So how do I write that? I take my explicit formula and I fill in n. That's the term I'm looking for. So a, that looks like a weird 9 or something. A sub 10 equals 1 times 2 to the n. Again, wherever I see an n, I'm going to replace that with 10 minus 1. And so how do I put that into my calculator? So this gets a little tricky. You guys start using some parentheses here. I can't put the A10 to my calculator, but I can simplify this part here. So I can say, I can say 1, and then I'm going to do parentheses 2. And now this might be new to some people, but do you see this caret key right here above the BC? If I hit that, that means to the power. Then I'm going to put this in parentheses because I don't want to just put, one of the mistakes students will make is they'll put 1 times 2 to the 10, and then they'll go minus 1. And that's not the same as 1 times 2 to the power of 10 minus 1. So I want to make sure I put that in parentheses. The parentheses are super important in this case. In fact, some students get so nervous about making that mistake, they'll actually just go, oh, well, 10 minus 1 is 9, so they just put to the power of 9 so they don't screw up. It's up to you. And so that equals 512. So this simplified to 512. So that means a sub 10 equals 512. Again, do not write this like this. A10 equals 512 because that is not subscript and it doesn't mean 10th term. You write it as subscript. So, let's try another. Hopefully you're getting it. Boom. You go ahead and try it really quick. I'm assuming you paused it and tried it. So it says it wants us to find the 12th term, but didn't give us any information. So the first thing I want to do is I want to identify some parts. The first thing I want to identify is what is the first term? Again, because this is a sequence and not a table, this first term is always whatever I see first, right? Unless it's otherwise labeled. So this is going to be a 1 again. How nice. And then I want to see if it's a difference or a ratio. Well, I know this is going to be a ratio because we're doing geometric right now, but sometimes you won't know. So I can try really quickly. Oh, that'd be +2, but 3 plus 2 is 5, so that's not going to work. But 1 times 3 is 3, and 3 times 3 is 9, and 9 times 3 is 27. So I know that I have a ratio, and that ratio is times 3, right? What do I need the times 3? No, I can just put 3, because it's assumed that a ratio is multiplication. And now I know my formula is a sub n equals a sub 1 times r to the power of n minus 1. So I just fill in the stuff I need. I need the first term, which we said was 1, the rate, which we said was 3, to the power of n minus 1. There's the formula. Now, to find the 12th term, all I have to do is substitute that n with the value I want to find. I want to find the 12th term. So I'm going to go 1, 3, and then I'm going to go to the power of 12 minus 1. And again, like I said before, students will often, because they're afraid to do this, mess this up, they'll just say, well, 12 minus 1 is 11, so I'll just go to the power of 11. But it's okay, you can write the whole thing in it. 1, parentheses, 3, close parentheses, caret key again, parentheses, 12 minus 1, close parentheses, and hit enter. And that gave me, whoa, exponential gets big quick. 1, 7, 7, 1, 4, 7, 177,147. That's the 12th term in this sequence. It gets big really quick. All right, so hopefully you get it from there. I'll do some additional problems, but this is all you need to know to go on. For the rest of you, here we go. Go ahead and try this one. All right, again, you're looking, you know we're doing geometric still, so here's another geometric problem. And before I can start doing this geometric problem, I need to label the parts. The first term, I know, is whatever's first in the sequence. That's going to be 100. Cool. And I don't always know that it's going to be a ratio. A lot of times I'm going to have to do the work to figure it out, but because we're just practicing geometric, I know this is going to be a ratio. So I say, is this getting bigger or smaller? And it says it's getting smaller. So in my head, I kind of think divide. I go, okay, well, 100 divided by what is 50? Oh, I think it's going to be divided by 2. And then 50 divided by 2 is going to be 25. But again, with geometric sequences, we don't use division. So how do I write divided by 2? Oh, that's the same as times by 1/2. Now, if you're able to go right to times by 1/2 instead of doing the divide, that's awesome. You're awesome. But if you can't, do the division and then think about how do I write that as a multiplication. So that means my ratio is times 1/2. Some people will say, well, Mr. Craig, can I say times 0.5? Yeah, you can do times 0.5. It's up to you. It can be a fraction or it can be a decimal, as long as you put it in there. So there's my ratio. Now I have to write the equation. The equation comes from a sub n equals a sub 1 times r to the n minus 1, parentheses, right? And now I just fill in what I need. Well, the first term is 100, and the rate is 1/2 to the n minus 1. And again, I write this because this allows me to find any number in the sequence. I can now find the 7th term, the 12th term, the 100th term, any term I want from this formula. So the explicit formula allows me to find any term in the sequence, but now I want to specifically find the 8th term. So I'm going to go a sub 8 equals 100 times 1/2. Everything's the same. The only thing I'm changing here now is I'm replacing the n with an 8. So the n gets replaced with an 8 minus 1. And now I can plug that into my calculator. I can't put a sub 8, but I can put the 100, parentheses, 1 BC2, close parentheses, and then a caret key's right here, and then that's parentheses 8 minus 1, close parentheses, and hit enter. And my solution is, whoa, it looks ugly, doesn't it? Doesn't matter. A sub 8 equals 25 30 seconds. If I could simplify that, I would, but I can't, so guess what? That's my answer. Some people might want to put it in a decimal. If I wanted to go decimal, that's FD. That's the same as 0.78125, but did that make it easier than this? They both look ugly, so you can put whatever you want, fraction or decimal, to make it easier for you. All right, so that should be able to do it from there. Let's go ahead and call it quits, and good luck.